James Webb has detected something extraordinary around Neptune. Clay-like minerals on tiny frozen moons, and even inside the planet's rings. To create those minerals, rock had to interact extensively with liquid water. But the objects carrying them today are far too small and far too cold for that explanation to make sense. The leading possibility is much stranger. Webb may be looking at material ripped from deep inside larger worlds that were destroyed billions of years ago. And there is one object in the Neptune system that could explain what happened: Triton. At first glance, Neptune's system appears peaceful. A distant blue planet surrounded by faint rings and a collection of small moons. But compared with the other giant planets, something about it has always looked wrong. Jupiter, Saturn, and Uranus all possess families of substantial moons arranged around them in relatively orderly systems. Neptune does not. Instead, almost all of the attention is dominated by one enormous moon, while most of the others are tiny bodies scattered around the planet. That enormous moon is Triton. And Triton behaves unlike any other large moon in the solar system. It moves around Neptune in the opposite direction from the planet's rotation. Its orbit is retrograde. That seemingly simple detail tells astronomers something important. Triton almost certainly did not form where it is today. Scientists believe it originated much farther out, probably as an object from the Kuiper Belt, the distant population of icy worlds beyond Neptune. At some point in the early history of the solar system, Neptune captured it. But bringing an object roughly the size of Pluto into an existing system of moons would not have been a gentle process. For decades, scientists have suspected that Triton's arrival may have transformed Neptune completely. The problem was finding physical evidence of what had existed before. Now, James Webb may have found it. Researchers used Webb's near-infrared spectrograph to examine 3 of Neptune's inner moons: Larissa, Galatea, and Proteus. They also studied material in Neptune's rings. These are not spectacular objects when seen from a distance. Larissa and Galatea are tiny compared with Triton, and even Proteus is only a few hundred kilometers across. But spectroscopy allows Webb to do something a normal photograph cannot. Instead of simply showing what an object looks like, it separates reflected light into different wavelengths. On Larissa, Galatea, and in the rings, Webb detected a feature associated with magnesium-rich phyllosilicates. In simpler terms, clay-like minerals. Different materials absorb that light in different ways, leaving behind chemical fingerprints. And when researchers examined those fingerprints, the first surprise was something they did not see. There was no clear spectral evidence of exposed water ice on any of the 3 moons studied, or in the rings. That is strange enough. Neptune sits in an extremely cold region of the solar system, where icy material should hardly be unusual. But then another signal appeared. And clay changes the entire story. These minerals are associated with extensive alteration of rock by liquid water. They do not simply appear because frozen water exists nearby. Somewhere in the history of this material, ice had to melt, liquid water had to interact with rock, and chemical reactions had to change the minerals themselves. But there is an obvious problem. Larissa and Galatea are tiny. Today, they are cold bodies orbiting a planet more than 4 billion kilometers from Earth. There is no obvious mechanism capable of producing the prolonged internal warmth necessary for extensive liquid water alteration inside objects this small. So the minerals probably did not form inside Larissa and Galatea as we see them now. They must have come from somewhere else. And this is where Neptune's missing moons return to the story. The researchers believe the clay-rich material may once have been buried inside much larger icy satellites. Bodies large enough for their interiors to heat up. Large enough for some of their internal ice to melt. And large enough for liquid water to remain in contact with rock long enough to alter it chemically. If Neptune once possessed such moons, they are gone today. But pieces of their interiors may still be orbiting the planet. To understand how that could happen, we have to return to Triton. Before Triton arrived, Neptune may have possessed a satellite system more similar to the one surrounding Uranus today. Several substantial moons could have formed around the planet in stable, relatively regular orbits. Then Neptune captured an outsider. A Pluto-sized body entered the system on an orbit completely different from those original satellites. Triton would not necessarily have begun with the tidy, nearly circular orbit it has today. Its early path around Neptune could have crossed directly through the region occupied by the original moons. Every passage would have disturbed the system. Gravity would shift orbits. Moons that had remained stable for millions of years could suddenly find themselves crossing one another's paths. Close encounters would become more common. Some moons could be thrown outward. Others could be pushed inward. And eventually, collisions could become unavoidable. Large icy satellites crashing together would not simply leave craters. They could be broken apart completely. Their outer layers would shatter. Their interiors would be exposed. And material that had spent enormous periods of time buried beneath kilometers of ice could suddenly be scattered around Neptune. The original moon system would disappear. In its place would be a disk of wreckage. Most of that debris would eventually be lost. Researchers estimate that perhaps only around 1% of the original material may have remained in the Neptune system. But even 1% could be enough. Fragments would continue orbiting the planet. They would collide. Some would be destroyed again. Others would gradually lose energy and begin collecting together. And from that debris, an entirely new generation of small moons could emerge. Larissa, Galatea, perhaps other members of Neptune's strange inner satellite system. Not ancient moons preserved exactly as they formed, but reconstructed bodies assembled from the remains of something much larger. If that model is correct, the minerals Webb detected were never created by the moons carrying them today. They are inherited. The chemistry belongs to worlds that no longer exist. And suddenly the strange detection of clay so far from the sun begins to make sense. A large original moon could have contained rock beneath thick layers of ice. Heat inside that moon could have melted some of the water. The water interacted with the rock and produced altered minerals. Then Triton arrived. The moon was shattered. Its interior was thrown into space. And billions of years later, some of that interior material is sitting on the surfaces of tiny moons where James Webb can finally see it. Essentially, the catastrophe may have turned ancient worlds inside out. Normally, reaching the deep interior of an icy moon is almost impossible. We can photograph its surface, measure its gravity, and infer what lies underneath. But the material itself remains buried. At Neptune, nature may have performed the excavation for us. And there is another detail that makes the mystery even more interesting. Proteus was also observed by Webb. It is larger than Larissa and Galatea, but the same magnesium-rich phyllosilicate signature was not detected there. That could mean Proteus formed from a different part of the debris field. Or perhaps its material experienced enough heating afterward to erase or transform the minerals. Researchers do not yet know. But all three moons revealed another hydrated material that scientists have not been able to identify. Its spectral fingerprint does not properly match the known materials in their libraries. So even after Webb exposed part of the story, some of Neptune's chemistry remains unexplained. And then there is Nereid. Nereid orbits much farther from Neptune and follows an extremely elongated path. For decades, that strange orbit helped create the impression that Nereid, like Triton, might also have been captured from somewhere else. But new Webb observations have challenged that idea. Another study published in 2026 compared Nereid's composition with other outer solar system bodies and combined those observations with simulations of Neptune's early evolution. The conclusion was remarkable. Nereid may not be a captured object at all. It may have formed around Neptune. And if that interpretation is correct, Nereid could be something extremely rare. A survivor. Possibly the only substantial intact moon remaining from Neptune's original satellite system. That gives us an extraordinary picture of what may have happened. Nereid may be the survivor of the old system. The inner moons could be reconstructed fragments of its destroyed companions. The rings may contain some of the same debris. And Triton is the massive outsider whose arrival changed everything. But there is one important twist. Scientists cannot yet prove that Triton destroyed Neptune's original moons. There is another scenario capable of producing similar material. A large differentiated object from the Kuiper belt, perhaps comparable in scale to Pluto, could once have passed extremely close to Neptune. Neptune's enormous gravity could have stretched it until tidal forces tore it apart. If that object had already developed a warm, water-altered interior, its destruction could also have scattered clay-rich material around the planet. Some of that debris could later have formed the small moons and rings we see today. So researchers are left with two dramatic possibilities. Either Neptune lost an entire original system of large moons when Triton arrived, or another large icy world wandered too close to Neptune and was literally torn apart. But whichever scenario eventually proves correct, Webb has already revealed the crucial clue. The tiny bodies orbiting close to Neptune appear to contain material that once came from deep inside something much larger. That makes these small, irregular-looking moons far more important than anyone might guess from their appearance. They may preserve a geological record of destroyed worlds. And the minerals inside them could reveal what happens when water and rock interact deep within icy bodies in the cold outer solar system. There is still much we do not know. We do not know exactly how large Neptune's original moons may have been. We do not know how much liquid water existed inside them. We do not know precisely how Triton was captured, or exactly how quickly the old satellite system disappeared afterward. And we still do not know what the unidentified hydrated material detected by Webb actually is. But now, for the first time, scientists may have physical clues from inside the worlds that were there before. Neptune's small moons are no longer just minor satellites orbiting a distant blue planet. They may be fragments of a planetary system that vanished billions of years ago. And Neptune's faint rings may be more than dust and ice. They may be part of the wreckage, a record of the moment when an outsider entered the system, ancient moons were destroyed, and Neptune became the strange world we see today. More than 4 billion kilometers from Earth, James Webb may have found the chemical fingerprints of that disaster still orbiting the planet. Not hidden beneath an ancient surface, but exposed, in plain sight, on the remains of worlds that no longer exist. This is valorous, because the truth is rarely on the surface.